Good evening, students. So today we are going to start a new chapter, and the name of the chapter is Force and Laws of Motion. So we are going to start this chapter, Force and Laws of Motion. That is a very important chapter in physics, class 9th. So let us begin. Today is 24 July 2020. And we are going to record this lecture for force and laws of motion. So what is force? How to define force? When we define force, then we have studied in our junior classes. That was a very basic definition which we have studied, that a push or pull is known as force. So this is how every student define it. But once we are in class 9th, so our definition should be little standard one. So force, we can say force is an external effort. So I am going to define force. Force is an external effort which can do following things. So few things we will discuss, that few effects we will discuss which can only be created by using force. So what is the first one? The first thing which force can do is to change the position of an object. Okay, force can change position of a body, or we can say force can move an stationary object. Suppose one object is stationary. Stationary means it is at rest. We can move that object by applying force. Suppose this marker is here. So it will remain here after even 3 hours, 4 hours, 15 hours. It will remain here only. But once we want to move it, what is required? The thing which is required to move it is force. Once we will apply the force, then it will able to move. This copy is in the table. I want to move it. So I have to apply certain amount of force. So force is the only cause which can move an stationary object. So this is the first thing which force can do. Another thing, force can stop a moving object. This is also possible, that one object is moving and by applying force, that object will stop. For example, your friend is moving in bicycle and you apply a certain amount of force. What will be held out? You can stop him. He is going in the bicycle and you just stopped it. You are just stopping it by the carrier, and you will find that you are able to stop once you will apply a justified force. Means the force which your friend is applying to move his bicycle, if you will apply the same amount of force, that bicycle will stop or not? Obviously that bicycle will stop. So force can stop a moving object. Is it clear? So third thing, force can change the direction of motion of a body. Suppose a body is moving in a particular direction and I apply a certain amount of force, then I will be able to change the direction of motion of the object. For example, Jasprit Bumrah, he is bowling the ball, and Rohit Sharma, he plays any shot in any particular direction. What will be there? The direction of motion of the ball is going to change. In which direction the ball will move now? It will surely it will move in the particular direction where Rohit Sharma is applying the force. So this is the effect of force which can be caused by force only. Now let us discuss another parts or another points which can be caused by force. That is, force can change the shape of an object. It is also possible that force will be able to change the shape of an object. This marker, this is having a particular shape. Once I apply a very greater amount of force, a very huge amount of force, what will be done? The shape of this marker can be changed or not? Obviously we can change the shape of this marker by applying a huge amount of force. So this is also the effect of force. We can change the shape of an object permanently. So these are the things which can be caused by the force. Along with it, we can discuss one more point, that is, force can accelerate an object. One object is moving with a particular velocity, then suppose we push it, we pull it, something like that. What will be held out? Its velocity can change or its velocity can retard as well. It depends on that whether we are applying the force in the direction of velocity or we are applying the force in the opposite direction of velocity. So I hope you understood these points, and don't worry about the notes. I will provide the notes later on. So I am just erasing it. Okay. Now students, so this was all about force. So force can be of two types. Force can be of two types. One is balanced force, and another one is unbalanced force. So what are balanced forces and what are unbalanced forces? This is what we are going to discuss now. So by name it is very clear. Balance means it will be equally balanced from both the sides. So for understanding it in well manner, let us consider one object. Suppose we have a block of certain mass. Say the mass of this block is m. Let us consider a force which is applied by a body, and F1 force is applied from this direction, from left towards right, and F2 force is applied from this direction. Now will this block move or not? So students, the movement of this block will depends on whether F1 is greater than F2 or F2 is greater than F1. If F1 is greater than F2, then this block will move in the direction of F1. If F2 is greater than F1, then this block will move in the direction of F2. For example, there are four Sikh are there, or four men are there. Two men are pulling one car in one particular direction and two men are pulling the car in the opposite direction. So the car will move in which particular direction? It depends on that which one of the two are applying greater force. So if these two forces will be equal, if F1 and F2 will be equal, now will the car move? Will the block move? No. Why the block will not move? Because the resultant of these two forces is 0. Why resultant is 0? F1 is equal to F2. Force is a vector physical quantity. So along with magnitude, direction is required. As you can see, one arrowhead I have drawn. So this arrowhead is indicating the direction. So F1 is equal to F2, but F1 is equal to minus F2 because direction is opposite. So what is the sum of F1 and F2? If this minus F2 will come in another side, this will become plus F2. Here is 0. So we find that resultant of F1 and F2 is 0. So the block will no longer move here. So we can say if the resultant of various forces acting on an object, if the resultant of various forces acting on an object is 0, then such kind of forces are known as balanced forces. Clear? If the resultant of forces acting on an object is 0, then such kind of forces are known as balanced forces. Is it clear? Now, balanced force cannot move an stationary object. For example, a block is stationary and I want to move it. If I will apply equal forces from both the direction, will this block move now? No. So balanced force cannot move an stationary object. The point which we discussed for force, this cannot be applicable for balanced force. Balanced force cannot change the direction of motion of an object. Suppose if a bus is moving in a particular direction and driver is having steering he is applying on left then on right, then direction will remain unchanged. So balance force cannot change the direction of an object. Clear? Balance force cannot change the direction. Balance force cannot move a stationary object. Even balance force cannot stop a moving object. One object is moving. Okay, one of your friend is moving by bicycle. You want to stop him. You applied a force of 5 Newton to stop him. But one of your friend is applying a force of equal 5 Newton in opposite direction. He is accelerating him. Now will the bicycle stop or not? No. The bicycle will move with the same velocity by which it was moving earlier. Yes or no? The bicycle will keep on moving with the same velocity by the velocity it was moving earlier. So this is the effect of balance force. We found that balance force cannot move a stationary object. Balance force cannot stop a moving object. Balance force cannot change the direction of moving object. So what thing can be done by balance force? But balance force can change the shape of a body. For example, I have a marker and I apply a force of 5 Newton. I just broke it. Now, if I will apply a force of minus 5 Newton, can I again join it? No. So, the change in the shape of the body will be permanent. So, balance force can cause one effect, that is to change the shape of a body for regular time. Is it clear? So, this is the effect of balance force and unbalanced force. Now let us discuss about another kind of force which we haven't discussed previously, and that is unbalanced force. So suppose, let us consider the same example. Let us consider a block of mass m and we want to move it. Suppose F1 is greater than F2. If F1 is greater than F2, the block will move in this direction. Yes? If F2 is greater than F1, then block will move in this direction. So the movement of the block will depend on that whether F1 is greater or F2 is greater. So here we found that the resultant of all the forces acting on the block is not zero. For example, suppose in this block we are applying a force of 5 Newton from here, 2 Newton from here. So what will held out? This block will move in this direction. By which amount of force this block will move in this direction? So answer is 3 Newton. How 3 Newton? Here 5 Newton, here 2 Newton. Both will be subtracted, as I have told you earlier that force is a vector physical quantity. So direction will be considered. So 5 minus 2. 3 Newton is the effective force in which particular direction the block will move. So resultant of force is calculated by considering the signs as well. So if the resultant of various forces, here the resultant is 0 or 3 Newton? 3 Newton. That's why the block was moving. So if the resultant of various forces acting on an object is not 0, if resultant of various forces acting on an object is not 0, then such kind of forces are known as unbalanced forces. I hope it is clear to you. So unbalanced force can move an object. Yes, of course. Unbalanced force can move a stationary object. Unbalanced force can change the direction of motion of an object. Unbalanced force can stop a moving object. One object is moving, but unbalanced force is capable enough to stop it. And even unbalanced force can change the shape of an object. So everything which we discuss for force is applicable for unbalanced force. So I hope that topic is clear to you. Now students, after discussing balanced forces, unbalanced forces, we are going to discuss about inertia. So let us discuss about inertia. Inertia. So what is inertia? You might be familiar with this word since before. If you aren't, then I am going to explain you inertia. So inertia is the property of the body. By virtue of it, it resists the change in its position, size, direction as well. So it might be difficult to catch all the terms together, so that's why I am going to write it inertia. It is the property of the body. It is the property of the body by virtue of it a body resists the change in its shape, its position, we can say, comma, motion or direction of motion. Actually we can say that our body is very rigid. So it do not want to change its position, its motion or direction of motion. If the body is in rest, then it want to remain in rest. If a body is moving, then it want to remain moving. If the body is moving in a particular direction, then it want to hold that particular direction. I will give you one example to understand this fact. For example, suppose one of your friend, say Manthan, and he is going for a journey in bus. So Manthan is sitting in bus, okay, and bus is basically in a stationary position. It is stopped, okay. So he is in the bus, and bus suddenly starts moving. When bus will move in forward direction, you will observe that Manthan will go in backward direction. If bus will go in forward direction, Manthan will strike back in backward direction. Will this held out or not? Have you observed it? This will held out. Why this will held out? Because once the bus starts accelerating, once the bus attains the velocity, start accelerating means it is gaining the velocity. Earlier the velocity was 0. Now it is gaining little velocity. Once the bus will start gaining the velocity, then the upper portion of Manthan is not in touch with the bus totally. The lower portion of Manthan is attached with the seat. So once the bus starts moving, the lower portion of the body also starts moving in the same direction. But because the upper portion of Manthan is not totally connected with the seat, so it will resist the motion. The upper portion do not want to move in forward direction. So for resisting the motion, bus is going in forward direction. So for resisting the motion, Manthan will strike back to backward direction. Is it clear? I hope you understood this. So this is how inertia, and the example which I have given you, actually inertia can be of 3 types. Inertia which we are discussing can be of 3 types. One is inertia of motion. Another one is inertia of rest. Third one is inertia of direction. My sequence can be wrong, but not the explanation. So inertia of motion, inertia of rest, inertia of direction. The example which right now I gave you, this is the example of which inertia, which kind of inertia? Inertia of rest, motion or direction. You should think in this way. The example which right now I gave you is for inertia of rest. Yes or no? This is example for inertia of rest, because the Manthan body was in rest, so it want to remain in rest. That's why once the bus started moving in forward direction, his body was coming in backward direction. So once the body is in rest, it want to remain in rest. So once we are moving in forward, it will strike back to backward direction. So this is the example of inertia of rest. Now students, we will discuss the example for inertia of motion. So what is inertia of motion? Let us discuss this. Now journey is going on, bus is moving with a particular velocity. Now suppose the driver applies the brake. Driver is stuck somewhere and he is applying the brakes. What will held out? Now, the particular passenger, the example which I was considering, Manthan, he will get in the forward direction. When brakes will be applied, his body will comes in forward direction. Why in forward direction? Because this is the example of inertia of motion. Now his body wants to remain in motion. So as soon as the driver applies the brake, because the lower portion of Manthan is totally connected with the seats. So once the driver apply the brake, then the lower portion of the body will comes in rest, but the upper portion of the body is not completely connected with the seats, so it will move in forward direction to resist the, which thing it is resisting now? To resist the brakes, to resist the motion, to resist the rest, because the body don't want to come in rest now. It want to remain in motion. So this is the example of inertia of motion. Is it clear? Now students, let us proceed to another example. So that is inertia of direction, another kind of inertia which we haven't discussed till yet. That is inertia of direction. So what is inertia of direction? Have you noticed once the bus is moving along left, when bus is moving along left, then is it left or is it right? It's left. Okay, so once the bus is moving in left, then the passenger will turn to right direction. You will observe this. Once the bus is moving towards right, the driver is applying the steering to the right, the passengers will go towards left. Why this will held out? Because this will held out because the body do not want to change its direction of motion. The body wants to move in the particular direction. So as soon as if the driver is moving the bus towards left, the passengers will turn to right. If the driver is moving towards right, the passengers will turn to left. This is just to indicate that the body is having inertia of direction. Now I hope that inertia is clear. Inertia is the property of the body. By virtue of it, it resists. Resist means rokna. Okay, so in Hindi I am telling this particular word only. Resist means rokna. The body do not want to the body want to resist. The body do not want to change its position, its motion or its direction. So I hope this is clear to you, inertia. Now mass is the measurement of inertia. Remember one thing, mass. If an object is having higher mass, then its inertia will be higher. If an object is having lesser mass, then its inertia will be lesser. So one fatty boy will have more inertia than a slim one. Okay, so I must have a very less inertia. Okay, I hope you understood this. Now, so inertia is the example of, inertia is the measurement of its mass. If mass will be greater, then inertia will be greater. What is mass? So I hope that you have studied this in chemistry. Still I am telling that the quantity of matter will define the mass. So how much quantity you are having of matter is the measurement of your mass. So I hope this is clear. So let us proceed to another topics. Now students, we are going to discuss Galileo experiment. Galileo experiment. Galileo experiment. So what was Galileo experiment? This is what we are going to discuss. So for this Galileo considered a frictionless surface. Frictionless surface. So let me try to draw a frictionless surface, and this angle and this angles are equal. The surface which currently I have drawn is a frictionless surface. What is the meaning of frictionless surface? The meaning is that no force will be available to resist the motion of the object once it will move in this frictionless surface. In friction, what is the role of friction? The role of friction is to oppose the direction of motion. This is what you have studied in your previous classes. Okay, the role of friction is to resist the motion. It always resists the motion of the object. So here the role is also similar, and he is considering frictionless surface. So there is no trouble at all. Once the object will start moving, it will keep on moving. This is what we have considered. This is what Galileo was considering once he was doing this experiment. So what was his observation? So let us come to that. He considered a mass. Say the mass is m. He just released this mass, means this spherical ball, from this frictionless surface, from the top of this frictionless surface. Once he released this, he found that the ball came here, moved in this frictionless surface, it started rolling up and rolled up to the total distance. Suppose this was s. Then the same distance this ball rolled up here as well, because these two angles were equal. So this was his first observation. Now what he did after this step, he did one more thing. After this step, he just reduced this angle. Here the surface will remain same, and here with respect to ground the angle is reduced. Earlier the angle was this much. Yes, now he have reduced the angle. It is little more clearant to the ground, to the straight. Now once he released this mass once again, he found that now comparatively this ball have covered greater distance. If here the distance was s, here the distance is s1, and s1 is greater than s. Clear? Is it clear? Now students, after this, once again he did this. And he again, in the third step, he have changed the angle once again. Now he found that the ball covered a very greater distance as compared to the previous two steps. Okay. Now the ball is covering a much greater distance. So by this observation, he came out to conclusion. By this observation, he just observed one thing. Once it is not flat, it is covering the same distance. It is little flat, the distance is increased. If it is further flat, the distance is more increased. So he came out to conclusion, if this surface will turn out to flat, purely flat in the ground, in the horizontal, then the ball will keep on moving. The ball will not stop now, because he have already used frictionless surface, so no force is there to resist the motion. Even the height is not there, it is horizontal. So it was his consideration that once the surface will be parallel to horizontal, then ball will keep on moving, it will not stop. Is it clear? Galileo experiment is clear. So students, let us go further. Now discuss more topics from this chapter, and now we are going to discuss about laws of motion. Laws of motion. Actually, you are going to study 3 laws of motion. So, first law of motion. This law of motion is also known as law of inertia. Law of inertia. So, first law of motion says, if an object is at rest, comma, it will remain at rest, it will remain in rest. If a body is in rest, if a body is in rest, it will remain in rest. If a body is in motion, if a body is in motion, it will remain in motion. Until any unbalanced external force is being applied on it. So students, what is the meaning of this? Law of inertia. If a body is in rest, it will remain in rest. Suppose a car is standing in front of your house and no one is starting it, or no one is applying the force. The car will move? No. it will keep on standing, parking there at that particular position. So if a body is in rest, it will remain in rest. If a body is in motion, it will remain in motion. So if a body is moving, it will keep on moving. This is not what I am saying. This is said by Newton's first law of motion. If a body is in motion, it will remain in motion. That is also true. So if this is true, you may ask, sir, once we are pedaling the cycle, it will stop after a certain time. Why? You cannot say that there the force is not there. Force is present. Which external force is present? Friction. Friction is actually working in your tire to stop the motion of your tire. So if friction is not present, then your cycle will stop? No, it will keep on moving. So how good the life could be if friction is not present? We are just pedaling our bicycle once and we are moving. Even till England, we are able to move. So this is first law of motion. If a body is in rest, it will remain in rest. If a body is in motion, it will remain in motion until any unbalanced external force. This is very important. This thing we already have discussed in the beginning of our lecture. Unbalanced external force. For moving the object, the force which should be applied should be unbalanced external. It cannot be a balanced force. Balanced force cannot move a body. So once you will apply the unbalanced force, it will move. Once you will apply the unbalanced force, it may stop. Okay, so for movement of the body, for stopping a body, you require an unbalanced external force. So this is first law of motion, and this is also known as law of inertia, because you already have studied inertia. Inertia is also defining the same thing. If you want to move an object, force is required. If you want to stop a body, force is required. So first law of motion is somewhere defining the law of inertia as well. That's why it is known as law of inertia. So once you want to move an object, you have to apply certain force. Once you want to stop a body, you have to apply force. This is first law of motion. So this is very clear. If a body is moving, it will keep on moving. If a body is at rest, it will remain in rest. Till when it will remain in rest? Until any unbalanced external force is applied on it. So I hope it is clear to you. First law of motion is clear to you. So students, two laws are remaining. Second law, third law, even momentum is remaining. Law of conservation of momentum is remaining. So this we will continue on tomorrow. I hope you understood the topics which we have covered till right now. So thank you. God bless you. Have a nice day.